Good afternoon. My name is Melissa Farrow, and this is my final project presentation for Dr. Wade Smith's Research 8260 class. STEM is an acronym that is receiving global attention in the spheres of public policymaking and education. The letters in this acronym represent the separate but related disciplines of science, technology, engineering, and mathematics. STEM disciplines are connected by a shared set of critical thinking and problem-solving skills, which are deemed critical for economic success and innovative competitiveness by many world leaders. There currently are discrepancies between the demographics of the United States population and the demographics of the students who are entering these STEM educational and career pathways. The purpose of my quantitative study was to explore the extent to which differences in college majors were present in students based on their gender and their ethnicity or race. This study has social implications for many categories of educational stakeholders, including students, teachers, and policymakers. Increased understanding about how underrepresented categories of STEM students make college major decisions is important because it may support the development of STEM educational pathways that meet the needs of a diverse population of STEM-capable students. This will also allow employers in the United States to tap into a more representative talent pool of critical and creative thinkers to retain global competitiveness in STEM industries. The research question for my study was, how do the factors of gender and ethnicity or race predict a student's college major? The null hypotheses were that there would be no statistically significant effect of gender or ethnicity or race on college major choices, and that there would be no interaction between gender and ethnicity or race in that college major decision. To test this hypothesis, I visited the National Center for Educational Statistics Data Lab to obtain the data set for my research project. Based on my research question, I chose to analyze an already existing secondary data set, which was based on a series of survey questions that NCES asked over 37,000 post-secondary students at colleges and universities across the United States. I was also able to use NCES's PowerStat software to perform a linear regression analysis on the dataset. The dependent variable in this regression was a student's choice of college major. I set math, computer, sciences, engineering, and technology as the reference category, with social and behavioral sciences, non-STEM fields, and undecided students as the comparisons. The fixed factors or independent variables for this analysis were gender and ethnicity or race. For gender, I set the reference category as males, with females as the comparison. For ethnicity or race, I chose the reference category of white, with Black or African American, Hispanic or Latino, Asian, American Indian or Alaskan Native, Native Hawaiian or other Pacific Islander, and students that reported more than one race as the comparisons. The results of the regression analysis of the dataset showed that every level of the data model was statistically significant, so my null hypotheses were rejected. Gender and ethnicity or race do influence the college major decision of post-secondary students. According to the R-squared statistic for this analysis, the effect size for this model is relatively weak. This means that only 6.4% of the variation in college major choice can be explained by gender and ethnicity or race. There are other factors that influence a student's decision to major in STEM beyond the ones that my research explored. When controlling for ethnicity or race, female students were actually more likely to choose a non-STEM college major than their male counterparts. When controlling for gender, Black or African American students and Hispanic or Latino students were also more likely to choose a non-STEM major than their white counterparts. On the other hand, Asian students and students who reported more than one race were more likely to choose STEM college majors than the students who identified as white. College major choices for American Indian or Alaskan Natives and Native Hawaiian or other Pacific Islanders were not significant in this model. There is no evidence that the differences in college major choices for these ethnic groups were due to anything other than chance. In conclusion, there are significant differences in college major choices between male and female post-secondary students, as well as between white, Asian, and students who report more than one race, and their Black or African American and Hispanic or Latino counterparts. This study has provided quantitative data to support the idea that current STEM educational pathways are a leaky pipeline to STEM careers, and that the diversity of students entering the STEM talent pool does not match the demographics of the population of the United States. Increasing understanding about how underrepresented categories of STEM students develop career choice actions like college major decisions is important because it may support the development of STEM educational pathways that meet the needs of a diverse population of STEM-capable students.